everyone. This is a presentation on a model to predict electrical energy output of a combined cycle power plant. This is part of assignment for ML Foundations for PM Coursera course provided by Duke University. So overview, the problem is we need to build a machine learning model to predict the electrical energy output based on the ambient variables. There's 4 variables that have been given. So if we look at the data set, there's 9,568 rows, also known as observations, across 4 features. And this data set also has an output which is given for the corresponding combination of features, and that's your electrical energy. And a quick glance through the data set, manual glance, shows that it's a clean data set. There's no missing data and there's no very major outlier that has been observed. So the model that we have chosen here is linear regression because the data is continuous and we are expected to predict a continuous data. And the metrics we have chosen for this activity are mean absolute error, mean absolute percent error, and R-square coefficient. So coming to the feature selection and run selection, I have chosen to run 2 sets, and the purpose of doing the 2 runs is to check if I can reduce the feature set by a feature, which is relative humidity. So the first run I have done with all the 4 features for the baseline metrics, and the second run I have removed the feature relative humidity and retrained the model and to check if the metrics will be better or worse. And the conclusion is that there is no significant impact of the removal of the third feature, which is relative humidity, and there is an extremely marginal improvement in performance, which shows that the feature relative humidity can be safely removed from the data set while the final training and deploying of the model. So coming to the dataset, quick look. So on the left is your run 1 dataset with all the 4 features, and run 2 dataset with the RH removed, and everything else has been kept the same. There is no change in any of the other variables. And now coming to the ML models and performance. As explained earlier, the dataset has both features and labels, which is why the ML model type that needs to be employed for this problem is a supervised learning model. Also, the labels are continuous and we are not classifying anything into zeros and ones, but rather we are trying to predict a number based on a given set of numbers, and hence linear regression is the most suitable algorithm within supervised learning. And I have chosen to use AutoML on the Google Cloud, and I've imported this data set and used AutoML to create the pipeline. And the split between training, testing and validation is 80, 10 and 10. And like I explained earlier, the purpose is to check if we can remove the non-contributing feature from the algorithm. So this is the comparison of the model performance from the AutoML screen. So the CCPP data set, which is the blue color, is the model with 4 features, and the CCPP dataset is the model with 3 features, and you can see the feature importance below, which also shows that even in a feature set with 4 features, the relative humidity, the parameter RH, is not of significant importance. So key observations from the metrics. First, a quick walkthrough of the metrics here. MAE is mean average error, and that's the average of the observed difference between observed and predicted values. And here the lower value is expected, which means that there is not a lot of variance between the expected, between the actual observed value and the predicted value. Mean average percent error is simply converting this into percentage. And coefficient of determination R²2 is, it ranges from 0 to 1, and higher value indicates the higher quality model. So if we see the difference between the metrics between the 2 models, model 1 and model 2, we see that there is a very negligible difference, and hence the conclusion of this case study or this experiment is that we can remove the model RH, relative humidity, and make our data set shorter for us with almost no impact to the performance of the model. Thank you.